Dear students, in this video I am going to explain one important topic that was asked so many times in public examinations, and this video is useful for AP and Telangana students also. That's why you have to watch the video up to last. The question is explain the Kirchhoff laws and derive the condition for Wheatstone bridge. That is the most important question. Watch the video till the end. Okay. So what are Kirchhoff laws or Kirchhoff laws? There are two laws are there. First law and second law. First law is also called as junction law. That is the algebraic sum of currents at the junction is equals to 0. This is called as Kirchhoff first law. And the algebraic sum of potentials in a loop, in a closed loop, is equals to 0. That is called Kirchhoff's second law, and this is also called as loop law. So now we will discuss in detail what is Kirchhoff first law. Kirchhoff or Kirchhoff, both are same, scientist name. Kirchhoff's law, first law is what? It is called as junction law. The algebraic sum of currents at the junction is equals to 0. Dear students, this is the one junction, clear? And here there are so many paths like this, clear? These are so many connections at one point. So here I am saying this is the I1 and this is I2 and this is I3 and this is I4 and this is I5 and this is I6, clear? So now I am saying this is the point P is nothing but here P is the junction. What it is? Junction. In a circuit, if you are finding like this, it is a junction. The currents which are enter, they are showing by the arrow mark inward. The currents which are enter into the junction, they can be taken as positive. And the currents which are leaving the junction, they can be taken as negative, and then the arrow mark should be outward. Clear? When they are moving into the junction, the arrow mark is inward, and when they are came out from the junction, that is arrow mark is outward. That's why here what I am going to say, at a junction the charges or the currents which are enter into the junction, they can be taken as positive, and which can go out or leaving, that is what? Negative. Clear? The currents which are into the junction, they can be taken as positive, and the currents which are leaving the junction, they can be taken as negative. So for this figure, what you have to say? Simply here I1, I2. Arrow, you have to observe the arrow mark here. Look at the arrow marks. I1 is entering, I2 also entering, I3 also entering. Arrow mark is into the junction. And now here you can look at the I4, I5, I6. How these are? They are leaving the S. They are leaving the junction. That's why here we have to write I1 is plus and I2 plus I3. I1 plus I2 plus I3. And I4 is leaving. That's what I write minus I4 and minus I5 and minus I6. That is equals to 0. The algebraic sum of current should be 0. So here algebraic sum means nothing but we are adding all those. The same equation should be written as I1 plus I2 plus I3 plus of minus I4 plus of minus I5 plus of minus I6. Then what is the same thing? I1 plus I2 plus I3 plus of minus minus plus of minus minus plus of minus minus. So I1 plus I2 plus I3 minus I4 minus I5 minus I6 equals to 0. From that what rate here I1 plus I2 plus I3 is equals to, you can take I4 I5 that side, then what you get? I4 plus I5 plus I6. You have to observe children here I1 I2 I3. What are those? I1 I2 I3 are the current which are enter into the junction, and I4 I5 I6, they are leaving the junction. Clear? That's why here simply what write? Sum of currents enter into the junction is equals to the amount of current leaving the junction. So this is the another form of the Kirchhoff first law. Sum of current enter into the junction, or amount of current enter into the junction is equals to the amount of current leaving the junction. So this is the Kirchhoff first law, children. Okay. The algebraic sum of potentials in a closed loop is equals to 0. This is called Kirchhoff's second law. It is also known as loop law. Clear? The algebraic sum of potential in a loop is what? It is 0. That is what we call Kirchhoff's second law or Kirchhoff's second law. So children, this is also very important. While you are preparing for the IP, not only IP and competitive exams also, this is very important one. So what it is? Algebraic sum of potential in a loop is equals to 0. Is equals to 0. That is sum of V is equals to what? 0. That is the children here we are going to discuss. So to understand this one, I am going to draw one loop here. As there are two cells or two batteries are given. So this is the first resistor, and this is the second resistor, and this is the third resistor. Clear? First resistor of resistance R1, and second resistor of resistance R2, and third resistor of resistance R3. So now this is one loop. Here this is the A, B, C, D. Now we want to find out the potential between these 2 points A and D. Clear? So for that there are two options are there. One is what? D, C, B, A. It is D, C, B, A, D. This is the one loop. A, D, C, B, A, D. That is another loop. Clear? So one is what? If you can start from D, C, B, D. If you can start from A, B, C, D, A. Clear? So children, to understand the Kirchhoff's second law, we have to follow some rules. Here, in case of long answer 8 marks question, no need to write all these explanations. Simply you have to mention the two laws and you have to directly go for which and which. But if they can ask separately for 4 marks or anything, whatever may be, and the same topic is important for competitive exams, that's why I am explaining in detail. Okay. Here now, the first thing is, first we have to select the path of selection. So in which path we have to move, that is we have to select. It is clockwise or anti-clockwise. And the second one is, you have to identify the direction of current in the circuit. You have to identify the current is in clockwise or anti-clockwise. And third one is here, the potential difference which is in the direction of current, is taken as negative. The potential difference which is in the direction of current, is taken as negative, otherwise it is in positive. If we can move in the direction of the current, then the potential will be taken as negative, and if you can move in opposite direction of current, potential is taken as positive. And fourth one, if you can go from higher potential to the lower potential, high to low, we can move from high to low, then epsilon is negative. If you can move from low to high, that means lower potential to the higher potential, then epsilon is EMF is positive. So when we have idea of these 4 rules, you can easily implement the Kirchhoff second law. So now here, this is the higher potential and this is higher potential. The current direction should be like this. What I am showing now, it is the direction of current in the circuit. So that means what? Current is in Anti-clockwise. Current is in anti-clockwise. Direction of current is what? Anti-clockwise. And we have to select the path of selection. So now I also decided to move in anti-clockwise. We have to move in anti-clockwise. So then we have to start from the point A. So here look, now I need some space. That's why I'm going to erase this one. Look here children. For loop, I am started at the point A to B, AB, next C, ABC, next D, and next A. So now it is closed loop. A, B, C, D, A. So first thing is what? We selected the loop, how it is in anti-clockwise. And second one is what? Current is also in anti-clockwise. Clear? Now we can start from here A to B. From A to B we are taken. A to B we are taken. Here I amount of current in the circuit. So what we know, potential is what? V is equals to IR, current into resistance. Current into resistance, that should be gives potential. Like that, when the I amount of current is comes here, now what is potential across the R1? I into R1, I into R1. The potential between A and B is what it is? I into R1. So I R1, it's clear. And we have to take either it is positive or negative. Just now only I told you what is that? The current is moving in this particular direction and we also moving in the same direction. That's why this is the negative. When we are moving in the direction of current, the potential should be taken as negative. Again here, current is I, resistance is R2. Here also potential is what? IR2. And this is also minus. And similarly here, the current is how much going here? I. Resistance is how much? R3. Then what you write? Minus IR3. So these are the potential across the R1, R2, R3. And now here I am going to say this is the epsilon 2 and this is the epsilon 1. This is the first cell of EMF epsilon 1 and this is the second cell of EMF epsilon 2. Here now when we are came to here, from that we are going from like this, lower potential to the higher potential. Then lower to higher, then EMF is what? Positive. That's why we have to write epsilon 2. And now these are same thing, lower to higher. This is what? Epsilon 1. So that's why here the algebraic sum of potentials are equals to 0. Clear? Then among that one, what write? Minus IR1 minus IR2 minus IR3 is equals to, we have to write minus epsilon 2 minus epsilon 1. Again minus I is common here, then what write? R1 plus R2 plus R3. Here what write? Minus is common, minus of epsilon 1 plus epsilon 2. Here if minus is common, what write? Epsilon 1 plus epsilon 2. Epsilon epsilon cancel. Then what write? I of R1 plus R2 plus R3 is equals to epsilon 1 plus epsilon 2. From that what write? I is equals to epsilon 1 plus epsilon 2 by R1 plus R2 plus R3. So this is the expression for amount of current in the that particular loop. So in this way, by using the Kirchhoff second law, we have to find out the current in the loop. So this is the what children? Kirchhoff second law. The algebraic sum of potential is equals to 0. Now let's go. Wheatstone bridge consists of 4 resistors like this: P, Q, R, S. They can be arranged like this, quadrilateral like P, Q, R, S. The names whatever maybe you can give R1, R2, R3, R4 also like that. Okay. So here Wheatstone which consists of 4 resistors. Here you have to observe in between the A and B one battery is connected. One battery is connected. So now here it is the battery or a cell. Thus we have it is higher potential and this is the lower potential. What we know, the current is moving from higher potential to the lower potential. and here I is the amount of current that should be supplied by the battery. Clear? The amount of current is moving like this. So here I. Clear? Now this point A can be acts as the junction. Why? Because here I amount of current is entered and the same amount of current should be splits into two paths. Splits into the two paths. That's why here I am going to, this is the I1 and this is I2. Clear? So I1 current is passes through the resistor of resistance P and this becomes out like this again I1, and I2 current is passes through the second resistor R and this be here I am showing it is I2. Clear? Again, now the point C is now here junction. Here how much is entering? I1, and again from that two paths are there. From that current is leaving. That's why here I3 is leaving and Ig also leaving. Here what is G? Galvanometer. The galvanometer should be connected in between C and D, and the amount of current that should be which is coming from the C and which is passes through the galvanometer that should be taken as Ig. Clear? So here how much current is coming here? Ig. And how much current it is? I3 current is passed through the resistor and now it is I3. Clear? And again now this point D can be acts as the again one more junction. Why? Because I2, Ig are entering and there is one path is there. From that how much current is leaving that should be taken as here I4. I2 is entering, Ig is entered, I4 is leaving. That's why here this I4 is passing through the resistor of resistance S. And again this point B can be acts as the junction. Why? Because here I4 is here entering, I3 is entering, and again that should be came out like I. So now here A, C, B, D, A, it is a loop. In that loop I current is entering, again the same amount of current is coming out from the loop. So that is the simply you have to understand what it is in the Wheatstone bridge. So if you can understand the diagram, you can easily understand the derivation. Simply I amount of current is supplied by the battery. At the point A is junction and current how much entering? I. That should be split into two paths, I1 and I2. I1, I2 are the currents passes through the P and Q resistors. And now at this point C can be acts as a junction. I1 is entering, Ig and I3 are leaving. And D is the junction, there I2, Ig is entering and I4 is leaving. And again at the point B, I3, I4 is entering and I is leaving. So now here for that bridge we have to apply the Kirchhoff first law. Kirchhoff first law we have to apply. What is the Kirchhoff first law? The algebraic sum of the currents at a junction equals to 0. So in the diagram at junction A, so what it is going on? I is entering, amount of current enter into the junction equals to amount of current leaving the junction. So I is equals to I1 plus I2. So this is equation number 1, children. Now at the junction C, what it is? I1 is entering, Ig and I3 is leaving. That's what you write. I1 is equals to Ig plus I3. This is equation number 2. And similarly children, at the junction D, I2 is entering, Ig is entering, I4 is leaving. That's why here amount of current enter into the junction equals to amount of current leaving the junction. Is equation number 4. And similarly now at the junction B, what you have to write? I3 is entering, I4 is entering. You have to observe the arrow marks. I3 is entering, I4 is entering. That's why I3 plus I4 is equals to I. This is equation number 4. So now the first part of derivation is here. We have to apply the Kirchhoff first law. And now we can go for, we have to apply the second law of Kirchhoff or loop law. We have to apply the loop law. For that, so here I am going to take now here A, C, D, A. For the loop, how we are taking here? A, C, D, A. A, C, D, A is the loop. A, C, D, A is the loop. Clear? So, A, C, D, A. That means what? We selected? Clockwise we selected. Clockwise we selected. And how is the current? We have to check it. So, we are going from A, C, D, A. Here, what is P? Resistance. What is current? I1. What we know? Potential is equals to what? I into R. Current into resistance. Current into resistance. Here resistance what? P. Current is I1. That's why in this case, here for the first time, the potential is what, right? I1 into resistance. That is what? I1 into P. I1 into P. And you have to, we are going from A to C. We are going from A to C. That means what? We are in the same direction of current. Current is also moving from A to C. Current is also moving from A to C. And we are also moving from A to C. That's why here the potential is negative. And now here G is the resistance of the galvanometer and Ig is the current through the galvanometer. Now across the galvanometer, what is the potential? G into Ig. So G into Ig. So now here we are coming from C to D. And the current also in the same direction, C to D. That's why here we can take this is the minus. Minus I1P minus G into Ig. Again now from D to A. D to A. It means that we are moving in the opposite direction of current. So here, what do you write? Current is I2, resistance is R. Then what right here? I2 into R. I2 into R. And that should be here positive. So the algebraic sum of potential should be 0. So this is equation number 5, children. Clear? From D to A, we are moving against the direction of current. That's why I am writing here plus. In the same manner, children, now I need some space, children. That's why I am here. I am taking the only loop only here. So here, for the next loop, here we have to take for the loop what is C, B, D, C. C, B, D, C, B, D, C. This is the another loop. That means simply what A, C, B, D, A should be divided into two loops. This is the off part, this is the off part. Now we are coming C, B, D, C means what? Again we are in clockwise. We are moving in clockwise. That's why here the potential from C to B is what, right? Minus I3 into Q. Why? Because we are moving in the direction of current. Minus I3 into Q. And here is we are coming from B to D. B to D. That means what? In the opposite direction of current. That's why it is what? I4 into S. Current is I4 and resistance is S. So I4 into S. And again we are moving from D to C and it is also moving in opposite direction. What did I write? Ig into G is equals to 0. This is equation number 6, children. So after that here, if there is no current through the galvanometer, then the bridge is said to be balanced. When there is no current passes through the galvanometer, then this bridge is said to be balanced. That's why here simply what you have to take? Ig is equals to 0. Ig is equals to 0 when the bridge is balanced. When the bridge is balanced, what you have to say? When the bridge is, Wheatstone bridge is balanced. Then what you have to write? Ig is equals to 0. There is no current passes through the galvanometer. Then what you have to write here? Simply where we have Ig, there we have to substitute the what it is? Ig value is 0. That means what here? From this equation, what right? I1 is equals to Ig plus I3. It means that what is simply what are here? I1 is equals to 0 plus I3. That means what? I1 is equals to I3. I1 is equals to I3. Clear? From equation number 2. From equation number 2, what right? I1 is equals to I3. And similarly here, from equation number 3, what right? I2 plus 0 is equals to I4. That means what? I2 is equals to I4. Clear? In the same manner. So children, I need some space, that's why I am going to erase this one. If you want to draw the diagram again, just go to the back and pause the video, try to draw the diagram. So from the equation number 5, children, from equation number 5, what you write? Minus I1P, this value is 0. So minus G into 0 plus I2 into R is equals to 0. That means what? Minus I1P is equals to minus I2R. That means what? I1P is equals to I2R. This is equation number 7, children. Clear? And next thing here, from the equation number 6, children. From the what, right? Again you have to substitute the value is 0. So minus I3Q plus I4 into S plus 0 into G is equals to 0. That means what we get? I3Q is equals to minus I4 into S. Clear? Again minus minus cancel. I3Q is equals to what? I4 into S. So now the equation number 8. So children, now we have to divide the equation number 7 and 8. Equation number 7 and 8 we have to divide. So this is equation number 8. 7 divided by 8. What is simply here? What is 7? I1P. I1P by I3Q is equals to what? I2R by I4S. So children, just now only we proved that I1 is I3. When the bridge is balanced, what you have to say? I1 is I3. So these two are cancelled. And again what you have to say? I2 is equals to I4. These two are cancelled. Then what you get? P by Q is equals to R by S. So children, this is the balancing condition of the Wheatstone bridge. P by Q is equals to R by S, children. So dear students, what is the use of Wheatstone bridge? Means Wheatstone bridge can be used to compare the ratios of two given resistors. The first thing is what? Wheatstone bridge can be used to compare the resistors of the two given values. And next one is what? By using this one, we have to find out the unknown resistance of a resistor. Among the P by P, Q, R, S, if you have idea about the three resistors, obviously you can find out the fourth resistance value. So children, this is about the Kirchhoff laws and Wheatstone bridge. So if you can understand this one, like, share, comment the video, children. Thank you for watching.